Here we have a solution of calcium bromide in water, has a concentration of 1.25 moles. How much solute in grams, so this is what we're looking for, is required to make 2.5 liters of solution. So we've been given some information here. This is ultimately what we're looking for, is the amount of solute we have to use to make this amount, this volume. And so I'm going to start with that. I'm going to have 2.5 liters. Draw my factor bar out one place. Molarity was given to me kind of as a conversion factor. I know the capital M means moles per liter. So I'm going to put 1.25 moles per liter. Cancel, cancel. And then I'm going to take the factor bar out one more place because I don't in actuality want moles, I want grams. But I have to go through moles to get it. And again, this is calcium bromide, which is 200 grams in 1 mole. When I calculate that, I find out it is 625 grams. Here we have 250 mils of a 6-molar solution, and I'm looking for moles. I'm going to start with what you're given, which is the 250 milliliters. I know because molarity is moles per liter, I know I have to change this from milliliters to liters. So I'm going to put milliliters here, liters here. 1 over 1,000. So there's 1,000 milliliters in a liter. But I am not looking for liters, I am looking for moles. And I know that I have a 6-molar solution. So I am going to put 6 moles per liter. Cancel, cancel. And my answer here would be 1.5 moles. Okay, atomic ratio and mass ratio. Atomic ratio, we've done this before. We have 1 calcium and we have 2 chlorines, or 2 chloride ions, and so we actually have a 1:2 atomic ratio. Mass ratio for calcium chloride, however, we have the mass of 40 grams or 40 AMUs for calcium, and then in this formula unit we have 2 chlorines. Chlorine, the mass for chlorine is 35, rounded to 35. And when we multiply that by 2, we get 70. So to get the mass ratio, we have to divide both sides by the smaller of the 2 numbers, which will always give you a 1 on one side or the other. And we have 1 to 1.75 mass ratio. And I just threw this in here. We haven't done this for a while, and I know that it's going to be on the final, on the post-test, and so I just wanted to remind you, here we have heat, or we could have time as well. Really wouldn't matter unless we were calculating heat of vaporization or something, and we're not. And so we always, on this heating curve, we start as a solid, then we go through the melting point, and the temperature at which it melts is the melting point. Then here we would have liquid all the way up. Here we would have both liquid and gas, and then here we would have all gas. So I just wanted to remind you, this is the boiling point temperature, which this is obviously for water. And if we were going backwards, then we would start out with a gas, and we would flip this whole line, And so we would come down here with the gas, then we would go through the condensation point, which would be the same as the boiling point. Then we would have liquid all the way down. Then, excuse me, during the melting phase, where we have both liquid and solid, we would go over then to the solid, and this, of course, would be freezing point, and then over to the solid. And I think that's it. Hope this helps. If you have any questions, let me know.